Chapter 25, Section 1, page 792. Planetary orbits. In the year 1600, Johann Kepler, a German mathematician, began to analyze the paths of the planets around the Sun. Kepler used data that had been collected for more than 20 years by the Danish astronomer Tycho Brahe. Kepler discovered that the orbit of a planet around the Sun is not a circle, but an ellipse. An ellipse looks like an oval, or a circle that has been stretched out along one axis. Most planets' orbits are nearly circular, and so are only slightly elliptical. Imagine that the path of Earth's orbit is traced on the top of a giant table. The plane of this imaginary tabletop containing Earth's orbit is called the ecliptic plane. The force that holds the planets in orbit around the Sun wasn't understood until Isaac Newton's discoveries about gravity. Recall that Newton's first law of motion states that an object in motion continues to move in a straight line at a constant speed unless acted upon by a force. This property of matter is known as inertia. Newton realized that the Sun must be exerting a gravitational force on the planets that keeps them in orbit. Otherwise, the planets' inertia would cause them to fly off into space. Gravity and inertia combine to keep the planets in orbit around the Sun. And that's a key idea. I'll say it again. Gravity and inertia combine to keep the planets in orbit around the Sun. Next heading, components of the solar system. Our solar system consists of the Sun, the planets, their moons, and a variety of smaller objects that mostly revolve in the same plane around the Sun. Another key idea, I'll read that again. Our solar system consists of the Sun, the planets, their moons, and a variety of smaller objects that mostly revolve in the same plane around the Sun. Recall that the ancients knew of 6 planets. Since the invention of the telescope in the early 1600s, 3 more planets have been discovered: Uranus in 1781, Neptune in 1846, and Pluto in 1930. Except for Mercury and Venus, all of the planets have moons. A moon is a relatively small natural body in space that revolves around a planet. Suppose you are surveying the solar system from a great distance. You may be tempted to say that it consists mainly of a single star, the Sun, with a few small objects revolving around it in the same plane. You would not be far wrong, since the Sun's mass is about 750 times greater than the mass of the rest of the solar system combined.